All right. So in week 7, we're dealing with functions, and we're gonna have to remember some stuff here. So this is a brief review. What type of functions have we learned so far? So linear functions, meaning a line, and you know y equals mx plus b. All right. For a quadratic, so this is where we're talking about a parabola, and we could make a parabola like that. And we just studied parabolas that open even to the left and to the right. But this would be something like y equals negative x squared, maybe plus 3, just as an example. A cubic function, so we have y equals x to the third, or x cubed, and it would look something like that. So this would be y equals x to the third, or cubed. That's cubic. And exponential growth is something that looks like that. And it gets really steep, really fast. Normally these, sort of the typical point is 0, 1. Oops. And so this is like y equals e to the x. Sometimes we have different bases. Let's see, I did write equations. Good. Okay. Absolute value function, so that would be something like this, whereas basically lines only, so y equals, and this would be absolute value of maybe x minus 2. If it had been shifted to the left by 2, it would be like a plus 2. So absolute value function looks something like that. And exponential decay is kind of the reverse process of exponential growth, and that tends to be something like y equals, let's say, e to the negative x. Okay, and then, a sinusoidal. Yeah, whether you know it or not, we've kind of seen some of this. And this is second semester, we are all over this. So it'll be something like y equals the cosine of x, whoops, or y equals the sine of x. Okay, so just general, that's what some of the functions we have seen before look like. They're graphs and equations. And so this lesson is basically on piecewise functions, where a piecewise function splits up the domain. So this is where the function is. So I'm going to say where, otherwise known as domain. And then this part over here is the what. What graph are we looking at? So occasionally there will be something that's the y value is a certain function for certain values of x, and it's a different function for different values of x. Tax bracket would be a perfect practical example where the domain would be your income, and then the function is the percentage of your income of taxes that you pay. So what we do is we see that x equals 1, the domain is split up. So we could make a coordinate system. And at x equals 1, we're going to draw some dotted line just to remind ourselves that the domain is being split right there. So at x equals 1, and so to the left of this line, there's going to be some graph. So to the left of x equals 1, we're going to have a parabola. And to the right, so for values of x that are greater than or equal to 1, we're going to have a line. So this is like y equals mx plus b. So let's see if we can draw this parabola. So for every value of x that is less than 1, meaning everything over here, we're drawing the parabola y equals x squared. So hopefully you can graph a parabola y equals x squared. Go through 0, 0, 1, 1, and let's see, I'm going to draw a little open circle there, and then 1, 1, and 2, 4, just squaring those values. So we're making it pretty precise. And notice how I didn't continue it, notice how I didn't continue it over there. And that's because we're only graphing this parabola for values of x that are less than 1. So this right here, that should be an open circle. Remember the difference between closed and open. number lines, inequalities, that kind of thing. So there's our open circle. Okay, and then next up, for values of x that are greater than or equal to 1, so everything to the right, we're graphing the line y equals mx plus b. I'm just going to draw this down here. So y equals mx plus b, not that you need a refresher, but negative 1x plus 5. So that line, we would start up at a y-intercept of 5 right here. And this line has a slope of negative 1, so down 1 over 1, down 1 over 1, down 1 over 1. Of course, I'm making my beautiful graph very messy here. But, so there's this line, and we want to make sure that we don't graph that for anything that is to the, this is only for values of x that are equal to or greater than 1. So we would have a little closed circle here at x equals 1. Notice how the graph is not to the left of our line at x equals 1. So sometimes if you have pencil, you can do what I did, and you can just graph these things and then delete or erase the graph from that region. All right, so here we have two different functions. They're split up at x equals 2. So I'm going to make a little coordinate system and split that coordinate system up at x equals 2 with a dotted line to keep me in check. So here's x equals 2. And to the left of 2, we're graphing the line y equals 3. Y equals 3, that's just a horizontal line. So I'm going to write out what we're actually graphing, y equals 3. And this is to the left of 2. So there's our line. And I might draw it in there, or I might write the equation to help us understand what's going on. And then here to the right of 2, we have y equals 3 halves x. So using a different color, so we're graphing y equals 3 halves x. And 3 halves x would start at 0, 0, and I would rise 3 and run 2, and then I would rise 3 and run 2. So I'd have this line like this, and that's real messy, so I'm going to clean it up. Because again, we don't want this graphed to the, and then this, get out of there. Alright, we don't want this graph to the left of 2, it's only to the right of 2. And this is weird, we have these superimposed open circles. We could draw it like that. So that would be our graph. Okay, so you definitely have to know how to graph lines and some basic parabolas, but you do know how to do that. On the back here, we're given the graphs, and we are trying to figure out the equation, the piecewise function. So my recommendation for this is that you say, oh, I know that's a horizontal line, so y equals 2, and oh, I know this is a line where using y equals mx plus b, the slope is 1, and the y-intercept is 0, meaning just y equals x. So next to the line or parabola or whatever, I'm writing the equation of it. So the equation of, I'll cross this one out. So the equation of this line is y equals x. Equation of this line is y equals 2. Notice how the domain is split up at x equals 1. So to the left, less than or equal to 1, we have the line y equals x. This is like y equals x. And to the right, I have y equals 2, to the right of 1. This tells us where it is. This equation tells us what it is. This is y equals this, and y equals this. Number 4, we have a parabola. So before I even look at the equation, hopefully I could check this out and be like, hey, this looks like y equals, and I have a slope of -1 and a y-intercept of 3. And I think I wrote that as 3 minus x. It's the same thing. And then here, I'd recognize that I have a parabola. that points downward, so negative x squared, and has been shifted up by 4. So plus 4, like that. And I think that I wrote that as 4 minus x squared. So that's our parabola. That's our line. They're split up at x equals 1. So to the left of 1 is the parabola, and to the right of 1 is the line. So you could have written the equations in this form, and that would be perfectly fine. Notice open circle, x is less than, and closed circle, x is greater than or equal to. Alright, so before I spoil the surprise, let's first see if we can write the equations. So I'm paying attention to where the domain is split up. Here it's split up at -3 and at 0. So we're going to have 3 different functions. Oh, goody. And the equations of these lines, this is y equals 1. This y equals, and this has a negative 2/3 slope. So negative 2/3 x plus 0, y-intercept of 0. And this line would be a slope of positive 2/3 x with a y-intercept of -2. So we're writing out just the equations of these lines. We learned that back in algebra. We see where the domain is split up, and now it's just a matter of piecing it together. Did you get that pun? Ha! Piecewise functions. Piecing it together. Okay, I'm on a roll. So f of x equals, so y equals, and we have y equals 1 for all values of x that are less than or equal to -3. And in between, see how we write this? When x is between -3 and 0, we have the line y equals -2/3 x. And then to the right of 0, so for values of x that are greater than or equal to 0, we have the line y equals 2/3 x minus 2. Piecewise functions. And then here, we did just study circles, so I think you got this. Radius is 2, so we know this would be x squared plus y squared equals 2 squared, or 4. In which case, if we subtracted x squared and took the square root, we could get, so I know that's a little messy, sorry, but this is y equals square root of 4 minus x squared, because we want the function written as y equals something. So that was the circle or semicircle. Here we have just y equals -1. And here, let's see, this is 1, 2, 3. The slope's 1, so it would intersect here. So this would be y equals, and the slope is x, and the y-intercept is -3. So we have this, and we have this. So we have this, sorry, to the right of 2, this in between -2 and 2, and this to the left of -2. So we see that our domain is split up between -2 and 2. So to the left, so for x is less than -2, we have the line y equals -1, y equals -1. In between, so for values of x that are between -2 and 2, notice the closed circles, the or equal to's, we have this y equals root 4 minus x squared, semicircle. Notice how it's only the positive root because it's only the top half of the circle. And to the right of 2, we have the line x equals 3. Kaboom! Piecewise functions. I think these are fun.